Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. In this video, I will explain the material about probability using tree diagrams and Venn diagrams. Before that, let me introduce myself. My name is Ahmad ulinnuha with name K13252020. Okay, let's get started. First is probability tree diagrams. Tree diagrams is an excellent tool for identifying the sample space and calculating the probabilities of a possible outcome in a set of events, whether the events are dependent or independent. And below is an example of probability tree diagrams. And the next, the question. Andy plays the games twice to write down all the possible outcome. Andy plays first game and second game, and then the probability of wins is 2/5. If we look at spinner up, here there are two sections for wins and 5 along together, so the probability for win is 2/5. If we then look at long well, there are 3 sections where you loss is 3. We on the level of the probability, the outcome, the loss is the 3/5. Okay, when we start with the best outcome and this plays the game twist is wins the games both times. We calculate that outcomes downs win and win. And then Andy calls win the first game but unfortunately lost the second game. So we call B wins loss. Then when we call lost first game but win the second games, so that what be lost wins, loss and wins. Finally the worst outcome for Andy is losing both games, so loss. When we have two or more events happen in order like this, a probability theory is really good ways of representing when things going on. So let's have a look at how we go through the situation in the probability tree diagrams. Considering in the first game there are two outcomes, wins and loss. If we now start on the left side the diagrams and follow this branch to the right side, you will see we have all 4 of those possible outcomes. From before, the next things we will do with 3 diagrams like this, like mark on the possible wins, loss, win, loss. Okay, the probability can range in the branch. In the probability wins 2/5 and loss 3/5. The second game wins 2/5 and 3/5 is lost. Then 2/5 wins and 3/5 loss. Okay, next. Example: Ria rolls a fire 6 sides dice and then throws a fire coins. If she rolls a number 6 and then throws tiles, she wins a prize. Complete the probability in the diagrams and calculating the probability the winning. The probability 6 is 1 over 6 because there are only 6 on the dish and 6 number altogether. The probability of not rolling 6 will be 5 out 6 because there are 5 numbers that are not 6 and 6 number altogether. Now let's move on the coins throw. So we are just throwing regular fire coins here. So the probability of throwing hands of coins is a half. Then analyze and a half, not 6. The probability of hit heads a half and tails a half. Okay, calculate the probability with a page. The probability is dash 6 and times. The probability is multiplying the probability 1 over 6 multiplying a half equal 1 over 11. Okay, next the example. A jar contains 3 red sweets and 2 blue sweets. 2 sweets were randomly picked from the jar one after the other without replacement. Okay, the question: what is the probability that both sweets were red, B, both sweets were blue, C, the color were different? The answers: let's use 3 diagrams to answer the question. First, we establish a starting from the start. We will draw branches to represent the possible outcome in the first phase. In this case, there are only 2 possible outcomes, red and blue. Notice we put the possible outcome at the end. The branch blue switch. The probability of each outcome should be stored on the branch on the first pick. There are 5 switches in the jar, so the probability drawing reds is 3 over 5. While the probability of drawing blue is 2 over 5. Now let's look at all the possibility in this second pitch. The top screen here is the scenario where the first switch drawn was red. The jar will still contains with 2 different colors, so still 2 possible outcomes represented by the branch red and blue. Now, if the first switch drawn was red, then there are only 2 red switches now left in the box from a total 4. So the probability of drawing a red switch on the second pick, given that the first pick was a red, is 2 quarter or a half. Also, if the first pick was red, there are still 2 blue switches in the case from a total of 4. So the probability of drawing is also quarter or a half. Now let's look at the scenario where the first switch drawn was blue. The bottom branch here is the scenario where the first switch drawn was blue. The jar still contains switches with 2 different colors, so we still have 2 possible outcomes in the second pick. Represent the branch red and blue. Now, if the first switch drawn was blue, then there will still be the red switch in the box from a total of 4. So the probability of drawing a red switch on the second piece given the first piece was a blue switch, there 3 quarter. And will the probability of drawing a blue switch will be 1 quarter, only 1. The tree diagram is complex. Now let's calculating the overall probability. This is by multiplying its probability along the branch of the tree. Recall its number length numerator over denominator and denominator. When multiplying fraction, so moving from the start, the probability of getting 2 red sweets is 3 over 5. Multiplying okay, this is outcome red and blue and red. Finally, blue and blue. The probability is multiplying and equal. This is 3 over 5 multiplying all half equal 3 over 10. Now, will the outcome red and blue probability total is 3 over 5 multiplying all half equal 3 over 10. And then outcome blue and red, the probability is 2 over 5 multiplying 3 over 4 equal 3 over 10. Then outcome blue and blue, the probability is 2 over 5 multiplying 1 over 4 equal 1 over 10. The question, what is the probability that a both switches were reds? Probability reds and red is equal 3 over 10. B, both switches were blue. The probability is blue and blue 1 over 10. You see, the color were different. This is means first red and the second blue, or the second blue and the first blue and the second red. Now, the probability red and blue, or probability blue and red, is 3 over 10 plus 3 over 10 equal 6 over 10. Okay. Next, Venn diagrams. A Venn diagrams is a graphical tool used to sort a sample space into meaningful groups which may assist in the calculating the probability of a specific outcome. Venn diagram example: in a class of 20 pupils, 8 of them like mustard, 24 of them like ketchup, and 5 of them like both mustard and ketchup. What is the probability that randomly selects that pupil will like mustard and ketchup? This is the symbol. To remember is probability A and B equal P A intersection P, and the probability A or B equal probability A union B. Union is two circle and the intersection is the in two both intersection in this. Okay. And likes both mustard and ketchup is 5. We read the 5. And the likes M is mustard is X. The 3 plus 5 is X. The total 3 plus 5 is X. And the like ketchup we read 19 because when we sums 5 plus 19 equal 24. This is same question. Okay, the question is probability likes mustard and ketchup. Probability mustard and ketchup same as the probability M intersection M and K. M intersection K equal 5 over 20. 5 is intersection. If the legs, put mustard and ketchup is 5, and the 20 and the 30 is the total of the in class 30 pupils, and this is 5 over 20 equal 1 over 6. Okay, the next, in a class of 20 students, all of them have brother or sister, or put 19 have a brother, 16 have a sister. Complete the Venn diagram. Okay, so the first thing is you make notice and helpfully capture this relative quickly. 19 have a brother and 16 have a sister. So if we do against, against 16, we end up realizing that we have 25. 20 plus 16. 19 plus 16 equal 25. So what is the implication if this well? This must mean therefore there is some have both brother and sister. So if we consider the arithmetic students, we got counts 25. Here that must means the 5 have both brother and have a brother and sister. Okay, so then if we know, that's left 14, because 19 minus 5 is 14. The sister is 16 minus 5 equal 11. Choose have a assist and when to have now. So we sums when we sums 14, 5 and 11, the equal is 20. This is a total of students in the class. Okay, that is the realized ways we use Venn diagrams. So finally, publish the students that class has a brother and sister. We have 5 over 20. The equal 1 over 6. Okay, the question. The Venn diagram below shows subjects that convey a group of 20 students. And the intersection account and biology is 3. And the question, what is the probability that a randomly selected student accounts? The accounts totally is 9 plus 3, this circle, and the probability is 9 plus 3 is 12 over the total of 20. So the probability is 12 over 20. The next, when we have a question, probability is selected student course biology is x plus 3. This is 11, and the over 20. 20 is totally, and then the probability account and biology. It is the intersection or the both course accounts and biology is 3. So the probability 20. So the probability is 12 over 20. The next, when we have a question, probability we select the student course biology is x plus 3. This is 11. And the over 20. 20 is totally. And then the probability account and biology. It is the intersection or the both course accounts and biology is 3. That's all from me. Thank you very much and see you.